So, you want to make a game and decided that your game needs infinite terrain procedurally generated. Yeah, well, this video is for you. You probably saw a lot of videos on the subject and probably didn't understand much of it. Well, that has happened to me as well, and that's why I decided to make this video. The most common thing people talk about is just height map generation for terrain and leave you to figure out the rest when you try to implement it. Well, things don't go as planned and you realize that you need more knowledge. Let's start with a small introduction of what noise is. And I'm not talking about sounds, I'm talking about the second definition of noise in here. Noise is basically just random signals that could be anything, like the static of an old TV. There is this guy called Ken Perlin that gives humanity with a thing called Perlin noise, and since then gradient noise became a thing. Gradient noise allows you to have smoothed out random generation, so that our signal doesn't spike and generate weird patterns that you do not want. In this video, I'll be using Godot engine to illustrate how to generate a beautiful world step by step from scratch without using outside pre-made sources. This way, you'll get a grasp of what is behind the complex worlds you see when you play in some games, like Minecraft or No Man's Sky. Now, for those unfamiliar with Godot, this won't be a tutorial on Godot basics, but rather I'm expecting you to have some knowledge of the basics beforehand. For this world generation, I'll be using 2D and I'll be creating 2D scenes. Let's first start by trying to create a map of the world without any code for now. Just some visualization. For that, we'll start with a Node 2D and we'll use Sprite 2D. In the Sprite 2D, we can start using a noise texture. And this noise texture, we set a size. I try to make this bigger just so that we can see more of it. Have a bigger canvas to paint. Now, the most important part, noise. Godot uses fast noise light, and it's quite easy to use and has a lot of options. You can create almost anything with it. Remember in the beginning of the video, I said people talk about height map generation and stop there? Well, it's so simple to do it. All you have to do is like create a gradient, choose some colors for it. Let's say I want a blue for ocean when it's like below the height, and then I want, I don't know, green for the grass in the middle. We can add some beaches here real quick, like proper color for some beaches, something like here. And we can add some more green, and we can add a smooth transition here like rocks to mountains. And we can have the snow there in the top that is white. And that's pretty much it. All you need to do to create a height map that is this simple. And that's it. All you need to do now is like randomize the seed, choose a random number, and you have your procedurally generated world. Thank you for your time. This is the end of the tutorial. Hit the like button and don't forget to subscribe to get more amazing content like this. See ya! Of course, this is not the end. This is just a demo of how simple you can achieve height map generation using a single noise. But now, let's understand what's happening here. You see that you have a blurred gray pattern here in the preview. Well, this is your noise. Since we're creating a height map, it's important to notice that higher values are likely to be mountains and lower values are likely to be valleys, right? Where we put the ocean. Well, yeah, that's true. But what if I decided to, instead of understand this as a height map, I understand this like a temperature map? Well, if we change the gradient to help us visualize it better, let's just create a new gradient here. let's say we want uh, red for hot, and we want blue for cold, and somewhere in between we will have like white here, a green to show us that the temperature is stable, and I don't know, an orange here to say, hey, this is kind of hot already. Yeah, well, the hotter colors will show us that where it is hot, and the colder colors will show us where it's cold. The hot areas we can interpret like a desert, and the colder areas we can interpret as snowfields. But notice that you don't have a very harsh transition between cold and hot. That's where gradient noise comes into play, because it allows you to create some organic transitions between cold and hot instead of putting them together like this. But let's say I want combined temperature and height. So how can I do it? That's where we can adapt an approach that we can see in Minecraft that's called biomes. Biomes are pretty much just a range of values that you want your biome to be generated in. Let's say you want to have, just for the purpose of this video, 4 noises: temperature, height, humidity, and let's say a random one, magic. Now, all you have to do is fill a table of all your desired biomes and have your biomes fill in that gap. I'll be doing this for the rest of this video, because knowing the theory helps idealize what you want, but implementing it gives you real grasp of what you'll be facing. So if this knowledge for you is enough, you can stop watching, but if you like to see me implementing it, just continue watching. We'll need a biome class, and for that we're gonna need our first script. So let's start by creating a script, call this biome, open it, remove what we don't need. Let's begin by naming this as a class for biome. Then we define its properties, like we said we're going to use temperature, height, humidity, and magic. But remember that I said that we need ranges. So we're going to need a min and a max for every one of these. So we can add a min at the end of each one of this and a max for each one of these. Alright, and for the sake of it, let's just create a constructor that will have those values. Plus, let's add some more here, like biome name and also the color we want for it. We're gonna see the usage of those later. So let's begin by defining biome name. So biome name, color, the min, the max, height min, height max, humidity min, humidity max, and lastly magic min, magic max. So let's just assign each one to each one. So let's just do a small copy of those in here. You can do Control Shift up to do multiple selection like this, and this time I cannot do it faster. You can press Alt to change the line you want stuff to be in. I probably should keep those together in here as well. Now let's do self.color I guess my best bet is to actually do a self dot beginning of each one of those. All right. Now that we have our biome class defined, we're gonna need a place to store them. And since we'll be probably generating those biomes a lot in a procedurally generated game, like when your character moves, so you will be generating them as they are moving. So we probably best have them in memory all the time. And the best way to do that is with singletons. So let's just create a new class here. Let's biomes. In this biomes, all we need to do is just like create new biomes. So let's do it by var. Let's say we have grasslands, and that's equal to biome new, and the name is grasslands. The color, let's say the color is, let's pick a nice color for grass. First green, yeah, get that in. Then the values. We first start with temperature, and I don't know, for that we can just go from -1 to 1. I don't really care. The next one is the height, because that's what we define here, by the way. So like we have already name, color, and all we need to do is like just fill in those. I'm gonna do those off camera to save you time. Now I've created all of these biomes here and filled in some values. I'll explain some logics behind it. First of all, you need to know that noises generate from between -1 to 1. So like if we have temperature, a -1 would be very cold and a 1 would be very hot. If we have height, a -1 would be very low and a 1 would be super high. So this way we can juggle between these values here and find the best combination of values for each biome. So let's say ocean. Ocean ignores temperature, ignores humidity, and ignores magic, and only stay to itself to height. So whenever there is a height value between -1 and 1, it will probably generate a deep ocean. Or a -4 to 0, it will generate an ocean. 0 to 0.1, probably an ocean beach. And this is pretty much the logic behind it. So you gotta find yourself a very, I mean, it's gonna take time, but you're gonna fine tweak these values a lot eventually in the future. That's why I created it this way in a table manner, like I just added some spaces here so that I could visualize better the values in a column, like if this were a spreadsheet. And I also added this array here that will be very useful to us in a moment. Now let's save this, and we need to have these biomes here as an autoload script. So we just gonna add biomes here and select the script and add. This way, whenever we need to reference the biomes, we just call it from everywhere inside the project's code. Now, the next step is to actually create the world generator itself. So we can grab this world view here. You see it in 2D. This is where we will be creating our world. So first off, let's attach script to this, and let's just call world generator. Alright, we don't need much of these, so let's get away with those. So first of all, we are gonna need noises. So let's start creating noise variables. So first one is temperature, which will be best noise light. So we said we're using 4, so let's create one for each one of these. Height, the next one was humidity, and lastly magic. Alright, now we're also going to need some gradients to visualize these noises when we need it. So let's just create temperature gradient, height gradient, the humidity gradient, and also the magic gradient. Might as well just add a noise here. Alright, next is to actually generate something. So let's begin by getting the noise values for a determined coordinate. And this will be useful when we are generating in chunk mode, because this way we can generate infinitely for whatever part of the world the player is in. So what we need is coordinates. And for this we will have var temperature equals to temperature noise dot get noise to the x and y. Next, height is equal to height noise dot get noise to the for x and y. Next is humidity noise for and lastly magic. And then we return these values. Next one is humidity. Next one is magic. So with this we have the noise values for each coordinate. Now we need another function to choose biome for noise values. And in here is where magic happens. What we need now is to select the right biome having the noise values we selected here. So we can just iterate through all biomes and see if the noise values actually match the range that the values are in. So I can already see that it's best if I create another method here, like func is noise values. Is within noise values. And we just pass the noise values here. And I'm gonna create a helper function here real quick just so that we can make it faster. to write. So return whether value is greater or equal than mean, not greater, yeah, greater or equal than mean, and value is smaller than max. So with this, we can actually just return noise between noise values dot temperature with self dot temperature mean self dot temperature max, and same thing but for other variables. Noise values height, noise values humidity, noise values magic. We just copy this. Now I think I've made a mistake. Okay, let's just check again. Temperature. Yeah. So what this will do is just basically return true if the noise values are inside the ranges we defined in the constructor here. And we go back to here and then we do like we create a new array, and then we do like if biome does is within noise values. That's how it's called. I'll just copy this, make sure. And we pass the noise values. This will return true or false, and with that we can just say candidates dot push. Weird. Oh yeah, candidates isn't it? Push front the biome. What this will do is that if the biome matches the value, so it is a candidate to be chosen. That's why candidates. Now, if we overlap the values, sometimes we can do that, it will want to choose more than one biome. And that's why I'm creating this candidates logic here. And to choose between the candidate, we can choose randomly, or we can just create another gradient. Not gradient, another fast noise like to choose the random factor. And why we do this? Because if there are great areas that overlap the biomes, then the random factor will make so that we generate smaller areas instead of generating, I don't know, biome dithering. This way, we will be able to choose properly the biomes and have the biomes create a small blob area there. And let's implement this logic now. So for candidate in candidates, we will do candidate. Actually, we can just create like a or index in candidates dot size, and since this is purely random, we can just use the numbers. We don't care about the biomes itself in here. This way we can just pick the index based on the amount of indexes there are in there. So to do that, we'll just sample. Actually, we can sample the random value in here. Random factor. And then we do random factor equals to random factor dot get noise duty to I and j. And we return that random. Put the colon here. That's it. So we know that the random factor goes between -1 and 1, so we can just like var random factor be something in between, like the dates dot size. So, and this goes from -1 to 1, so we can just add 1 here, and it will go from 0 to 2. So we divide this by 2, and then we'll have a value from 0 to 1, and 0 to 1 all the way to candidate size. So let's say we have 3, it will go between 0 and 3, right? Yep. And we only need to choose, so like chosen index is equal to this, and this is a floor. Why? Between this and why a floor? Because we need an integer, because index is an integer. And just to make sure we don't select the candidate size, let's reduce a very small amount in here. So it will floor, like if there's 3, it will floor to 2. Okay, and now let's fix this. I think I need one here. Okay. Times candidate size. Well, operand int to fast noise. Yeah, because we need this. Alright. Go. Now we need a chosen biome. So var chosen is equal to, let's make it equal to a filler. In case we are not able to have any candidate, then it will be a filler. And if there is only one candidate, this whole thing will just select the candidate we need. And chosen is equal, actually we don't need to iterate this. Chosen, we need an if candidate size is greater than 0, meaning that there are candidates, then chosen is equal to candidates and the chosen index. Colon here. Alright, so if we have candidates, then we will choose between the candidates, get the index, and the candidates. And then the chosen biome will be the candidate with the chosen index. If there are no candidates, it will just be the filler. And we return the chosen biome. But that's what this function is for. So yeah, we have the noise value for the coordinate and we have the biome for the noise values. Perfect. Now let's get to the drawing part of the code. We're gonna need images. So let's create some images. Var image, var biome image. Like this, yeah. Var temperature image. This images is where we're gonna fill in the data we get from the biomes or the noises. So like the biome image will be filled with the color of the biome, the color we define in here. And the other images are gonna be filled with the gradients based on the value we get from the noises. So let's create a func ready. So when we create this scene, the first thing we're gonna need is to actually allocate space for this biome, for these images. So biome image is equal to image, won't create from data, no, just create. And we pass in and width and height. This can be your world size. Actually, let's create a world size variable. And we can export this world size, and let's begin with 1024, just so we're sure. So world size. What is this world size? This basically for this application only will be the size of the image we're going to fill in. So we'll have world size here, world size in there. Use meet maps, we don't need them now, so false. And the format RGBA. RGO image format RGBAH. The image format is basically just how much space it's going to allocate for each pixel and what is going to be stored in the pixel. In this case, we're going to store RGB. Actually, we don't need the A part since we're not creating transparent tiles or pixels. So temperature image would be the same as this. We're just allocating space for each of these images, so we have where to paint. Basically, we're creating a canvas here. Next, since we have the images already, we're gonna need a func narrate world data. Now this is where we fill in the data. For this, we're gonna need iterate between each pixel in the world size. So for I in world size, for J in world size, this could be X and Y, but I prefer to use I and J for iterations. I don't know. I've always did generic I, J, K, and that list goes on. Next, we need to say, hey, we need to the noise values in this coordinate. So get noise for coordinate. We have I and J. And this is our noise. Next, we need the actual chosen biome for this coordinate. So we will do biome is equal to choose biome for noise values, which we already have. And lastly, we just need to fill in the world data. And since we have all the data now that we need for filling, then we do biome.image is equal, dot set pixel at y and j to be the color of the biome. Perfect, right? Next, the temperature image is a little bit different because gradients samples go between 0 and 1, and the temperature image goes between -1 and 1. So we're gonna have to fix that. It's not that difficult though, we already did this before in here. So set pixel at I and j to be the temperature gradient dot sample, and the offset is where in the gradient we're gonna pick this. So this is gonna be plus 10 noise values dot temperature, if I can spell this right, plus 1 divided by 2. Simple as that. And I'm gonna need this and this in here. That, and this one's from the map. Yeah, perfect. Now let's just avoid to say they are integers so we don't get integer value. And we repeat this line for every image we have. And we get the right name for the noise value we're sampling. And that's it. Now we have all these 4 images. Great. Now that the world data is generated, let's generate it on the start of the scene here. We only need once, so let's just do it at the beginning. Next is to visualize it. And we already have our sprite 2D, so let's just reference it already. Var world sprite equals to sprite 2D. Yay, great. Now at the beginning we can just paint it with the sprite 2D. We can just paint it with the biomes we generated. So world sprite dot what was it called again? World sprite dot texture is equal to image texture dot create from image biome image. Great. This is perfect, and I'm pretty sure we can already test this, so let's try it. Yeah, errors. Get noise to this on a new value. Oh, right. We forgot to create the everything actually. Everything is empty here. So let's create a new temperature, a new this, a new this, a new this. And temperature gradient, let's create new gradients. And random factor is noise. All right. So for now, let's keep them as is so that we can test the scene. And it's take a while because let's be honest, it's generating like a million biomes pixels. Yeah, thousand, yeah, million. So it's gonna take a little while to generate. And here we are. There we have it. As you guys can probably see by this purple color here, we're pretty much having magic forest everywhere. And the issue lies with having badly defined the noise values for the thing. And also because all the noises are the same. So basically whenever we have like height above 0 and it's not ocean, it's the same value for magic. So everything above 0 is magical in my biomes list. And since this is the same noise, we get weird values. But you guys may notice that this images clip is actually not the whole image. So we are gonna create a small camera panner here so that we can move around and check this. All right, let's begin creating the camera real quick. So yeah, the child node, this is a camera 2D. And the camera 2D, we attach a script. Camera 2D, yay. In here, there isn't much would need to be done, but just so what we actually need is an input event. And if the camera is enabled, we process this. And if this is an input mouse move motion, input event mouse motion, and is this, then what? And event dot button mask to input. Wait, let me check real quick what it is. Mouse button mask middle. Alright. So that we can pan with the middle mouse button instead of the left click. I like panning with those. And then how we need to do is like position is minus equal event dot relative divided by zoom. So what this will do, it will just pan the camera. Yes, here we are. So as you can see, if I click middle mouse button, the whole thing moves. Great. You might be noticing this jittery thing. It's actually caused by VSync. So you can actually go into general here. I think it was under window. VSync mode disable. That's right, we don't want VSync at all. Alright, back to the world. As you can see, oh yeah, we can actually just delete this so we don't keep saving weird stuff. And in here we select the noises. So as you can see, all the noises are equal. And we can just get around there just by changing the seed. Like here, changing the seed like in here, changing the seed in here. And this, there are 3 noises here. Oh yeah, there's one more here. Alright, with the seed values different, we're gonna have a much more interesting world because let's be honest, if all the noises are equal, then you wouldn't have much difference between the values in the ranges and end up with something like that full magical forest world we had before. And let's restart and see what we get. All right, here are the biomes generated. As you guys can see, we have like lots of biome generated and it's very random. But one thing I want you guys to notice is that the red biome in here, and this one is the filler. And this is happening because I did not properly manage my biome values. So in your case, you're gonna be tweaking the values a lot until you don't get these filler biomes anymore because they're pretty much nothing. They shouldn't be generated at all. They're just a filler. And in case you might be wondering, hey, why don't I just fill this with a biome of my choosing to be the default biome? Well, you can, but in a practical application, what will happen is that, let's say you choose to fill this with ocean. Then you're gonna have oceans in the middle of the continent that your world have. And this is gonna be weird, really weird. In case you guys are wondering, this purple here, I'm pretty sure this is boreal forest. And it's not ocean. Ocean is this aqua color here. And another thing you guys may be noticing is that we don't have rivers. And that happens because, well, while the noise values can be generated between -1 and 1, they'll generally stay in between -0.3 to -0.3. Yeah, because probability, this is pretty much a bell curve probability, and the only way to change this is to actually change the noise. So like in here in the fast noise light, we have lots of noise options. Like we have, let's say, cellular. And you might be thinking, yeah, this is the same noise, haven't changed anything. Yeah, well, it did change, but the frequency is too high for us to notice. So let's lower the frequency a little bit. Let's go back to simplex. As you can see, simplex is pretty much almost like Perlin noise. The only difference is how they are actually computed. But cellular is a little bit different. It creates cells, and each cell has a method to get the value, which is this return type. So the further away we are from the cell center, the higher the value. That's why we have some high peaks in here. We have distance square, which exaggerates a little bit the distances. We have other options in here as well, like distance add, the distance to, and we have other options here like fractals. Fractals are very powerful tool. We have to make the noise a little bit more noisy because pretty much what a noise is, like a simplex noise, is just a sine wave with a little bit of variation in the amplitude. And what fractals are smaller sine waves that are added to this bigger sine wave, and this adds a lot more randomness. We can actually notice this if we increase the frequency a little bit, like something like 0.5, and I just do no fractals. See? A huge sine wave. But with fractals, smaller sine waves get added to it, adding more detail to the noise. And you can do that with pretty much anything, like fractals to cellular. And other thing we have here is the domain warp. Domain warp actually makes it looks a little bit different. It adds this effect here that actually warps the image a little bit, creating like some more sharp edges. If you can notice, like let me increase it a little bit. Okay, too much. Too much, like reduce the frequency to match a little bit this top one. As you can see, it creates like some warps in the image, and it makes it a little bit more sharp. So for the temperature, it's actually gonna be cool because it will look like smoke. Let's just generate a little bit and see how it looks like in the world. All right, here we have a world. Lots of filler still, but the temperature is a little bit different. So not sure if you can see it properly, but um, it will probably show in the shape of the biomes that depend on temperature, like desert or something, but I can't seem to find a desert here because my values are ultra weird again, so might as well just fix that. So we have pretty much set up the world generation. Now, what you will need to be doing if you're actually taking this to a higher level is to actually proper configure the noise to be like what you think they should look like using domain warp, fractals, whatever, frequency. Frequency, pretty much how big the sine waves are. So if there's a lower frequency, the sine waves are bigger. This is great for if, let's say, you're creating a huge world and you don't want the biomes to change so often, so you just lower the frequency. And all the noises in here are pretty much the same, just change the seed. So you'll be changing this. And the seed thing is a very powerful tool because let's say you want to create the same world every time, so you just set a seed and then you create like a worldwide seed, then just set other seeds, like each noise seed should be something that the world seed, it's dependent on the world seed. Like let's just create this real quick. So like word generation, we can export the very top thing. I want to export a var seed that is an integer, and we can set it to be like, and when we begin the world, all we need to do is just random this seed. So like the temperature noise dot seed is equal to seed variable plus something. We can do this pretty much for every other noise. Here, seed plus something. Let's say I want this one to be the seed square. And I want this one to be seed times 2. And this one to be just seed itself. And I forgot to add the dot seed at the end of each line. So now you don't have to set the seed here anymore. And you just have one value for the seed, and whenever you change the seed, you're gonna get the same world. So let's just change the seed here real quick. Now reduce the world size a lot because it's super slow to load. And let's check it out. See? We get totally different shape. I mean, it's gonna be hard to notice that we get a different shape because the world is different every time I load the screen, but yeah. And a great powerful thing is this exports because you can configure the world just from here instead of having to manually define the values. One last thing you might be wondering is, hey, I have a filler and I'm not quite sure what value I'm getting at some place at certain coordinate. So a good thing would be to have debug modes, and you don't want to be like printing stuff every time, right? So what we'll do is actually create UI. And why, you say? Because it's better this way. I mean, this is just a word generation tool, so why not have it properly display the values, right? So let's just create a panel container here so that we have a small background. Instead of here, we create a label. And with this label, we will display the coordinates like x equals to something, y equals to something else. We are gonna need as well like the values for the noises, like temperature 0.0. I'm just doing this to get the size correctly, like height minus 0.0. Another one was humidity minus 0.0. And I mean, let's use 3 letters so we don't break the pattern. Lastly, temperature, the humidity, and magic. Alright, we can actually set the precision in text later. We don't have to worry about that now. And for the last part, we actually want to see which biome we are seeing at the coordinates. So, alright, next we are, let's increase this panel a little bit more. Let's make the label shrink to middle, layout shrink to the center. No, container size shrink to center. Increase a little bit more. If you're wondering, this blue line here is your screen size. You can define this here in the viewport with it. It's very helpful to know this when you're creating UI. Alright, another thing we want is another panel container. Like, let's just add a new channel, the panel container, so that we have this small transparent background thing here. And we want to anchor this to the top right. Anchor, yeah, here, and move a little bit here. Give me some space, and let's create an option button. The option button in here, we are selecting the overlay. So the overlay, it's the items here. So we're gonna wanna have a biome overlay. We're gonna wanna have a temperature overlay, height, humidity, and lastly, magic. With these selected, we just need to have a predetermined one. Alright, cool. Now, this one, let's hook this to the code real quick, like whenever the item is selected. Let's do this to the node 2D. Alright. So this one is quite easy. All we need is like match the index and to know what index is. So like if it's 0, then we will have the is world sprite dot texture dot update. Yep, update, and have the biome image. Also, we just need to copy this, create one for each image we have. So like temperature image. The next one is height image. The next one is, what was this again? Humidity image. Lastly, magic image. All right, this one should be working already. And the other thing we need is the changing the label, right? So for that, we can do that really quickly. We just can do that in the process method. We're not gonna use delta. And in case you're wondering why I'm doing this in the process and not the physics process, it's because mouse position can change between every frame, and physics is just like 60 frames per second or lesser if you change in the product settings. And since we want just to see what is in there instead of having to do physics calculation, it's better we do this in here. So let's get the mouse position. Mouse pose is equal to get world mouse position. What was it again? Get global mouse position. Yeah, that's the one. Next is we have a mouse position. Now all we need to do is to actually use these methods in here. That's why I separated in methods, because you only need noise values. Whoa, what have I done? We only need noise values here for the mouse position. Should have made this into a vector too, right? Instead of thinking I could just passing the mouse position. Alright, noise values. Then with the noise values, we can grab the chosen biome for with this noise value. So choose biome for noise values, noise values. Lastly, but not least, no, we have everything we need. Yep, we do. Now we need a reference to the label. So already var info label is equal to this. So, oh yeah, and a pattern string. So var pattern string. It's actually just simple. If I could see this again in the label. So just I have a view of what I'm seeing. Like X, it's a decimal. Y, it's a decimal. Temperature. I mean, this is a new line, so temperature equals to a floating, and you can set your precision here, so like .3 float, and I it's .3 precision float, new line, humidity is percentage 3 float, and the last one is magic, it's another percentage. That's 3 float. And lastly, the biome we selected, it's a string. Alright. Since we are always gonna use the same pattern, it's best that it's const in here so that we don't keep creating this all over and over again each frame, right? All we have to do now is fill the info label dot text with the values we have, which is pattern string and the values. Mouse pulse.x, mouse pulse.y, noise values dot temperature, we change for height, humidity, and magic. And the last one is the biome dot name. Yay. This line got a little big, but you can actually break it, but we don't need it, right? So let's generate the scene again. And here we have it. So let's say we have this filler here. And the chosen biome doesn't want to display the name. It's because it's biome name. Yeah, it was biome name. So you can actually see. Wait, this is not right. Huh, interesting. Temperature, height, humidity, magic. Yeah, like magic value 0. Something is wrong in the mouse position. I'm not sure what's happening. Oh yeah, I get it now. It's a stupid thing. Like the image is centered, so the 0 of the image is actually in here. But to the mouse, it's minus something. We can just change his real quick with this offset. We remove the centered. All right, all right. Now, if we check the values again, there should be something negative here, and there should be something positive. Yep. As you can see, we almost don't have any values that goes above 0.5 or below minus 0.5. And that's what I tried to tell you, that the probability of those values getting picked is very low. So you might want to adjust your values having that in mind, or you can actually do some weird math with your noise values. Like we can grab noise values from here, like temperature noise. We can actually do like add 1 to it if we want to, or get even crazier than that. And this is where you're gonna do it. And that's why we create a different method for it, so that we know where to change the values we need. Same thing with generate world data. If we only need generate world data, like when we actually fill in the world, we only call the method we need to fill in the world, which is generate world data. And the generate world data will call the respective method for each thing. All right. Now we have this beautifully generated world. Let's just increase the size a little bit again. So we have this beautiful generated world in here. And what do we do with this? Because this is pretty much just pixels in an image, right? Yeah, you're right, but you have to use your creativity a little bit, right? So let's say you have a tile map of the world, and for each pixel or each tile position of the grid map, you can choose different tiles for it basing on the position of the pixel in this image. Let's say we have grasslands here, and in the grasslands you just fill it with grass, and the ocean you fill it with water. Forest, you can generate another random noise that, and just pick where the values are somewhere above 0.5 because that's already very rare, and add some trees to it, you see? And you can actually save this image and save all the positions of this part of the world in an image instead of generating like a text file filled with things, because in an image it's gonna be very much shorter than a text file to save it. And when you load, you just load the image and you don't have to generate it all over again each time you open, because you might be noticing that it's taking a while to open. I'm just cutting it in here in addition, but that happens because I did not optimize this at all. Like, we just created this from scratch, right? And we can optimize this in a few ways, but this is outside the scope of this video. And for now, I think we have pretty much everything we need. So there you have it. You have created a world and different biomes in it. I think this is the scope of this video. Let me know in the comments if you guys want to follow up on this video, something like a structure generation or real application on a game project, chunk management, or like better optimizations. Also, you might want to check the Discord link in the description if you feel like it. If you like the content, show it to YouTube so that it can recommend to other people as well by hitting the like button. And if you want to see more content like this, like more advanced topics instead of just basic tutorials, you might want to subscribe as well. So stay safe and have fun.